Hello, boys and girls. My name is Sam Tyra from the Florida State University, and I work on an area called aerodynamics, which is concerned with how things fly. So we're going to talk about flight. Okay, so first I'd like to talk about what flies. Here we have animals and aircraft that flies. So on the top left, you'll see a bald eagle flying and perhaps trying to catch something out of the water. We also have helicopters, airplanes. This airplane is the original airplane from 1903, when the Wright brother flew for the first time. And we also have the balloon, which flies. And we'll talk about this a little bit more and try to relate it to your morning lesson where you learned about the weather balloon. Okay, but before we do that, I'd like you to first talk as a class about what else flies and discuss some of the other things that you know that flies.
Take a few seconds to write some things down. What are some other things that you can think of that fly?
So, let's take a look at some of the other things that fly. We know that insects fly. You have seen mosquitoes, housefly, butterflies, for example. Also, some of the fishes fly. These are called the flying fish. They jump out of the water, spread their fins, and they fly. You also know that we have aircraft or airplanes that fly. You've seen them. Some of you perhaps have flown on them. But nowadays, you can also have a human being fly with the aircraft. There's a guy who has a turbo or a jet engine on his wing and flying in formation with the aircraft. I'd like to see if you can find this video and take a look at this. It's kind of exciting.
Inbound for the face.
How was that video? It was pretty exciting, wasn't it? Two guys flying in formation with the aircraft at pretty high speed. I think it's pretty cool. Okay, you can also find a video of a flying or a gliding snake. They can also take off from a high place and kind of glide a long distance. I want to see if you can find that video as well.
For all their prowess as hunters, jungle snakes have enemies too. So some of their weaponry is defensive, designed to ward off an attack before it's too late. But sometimes the best way to fight is flight. One snake has become a consummate escape artist. The paradise tree snake lives in Southeast Asian rainforests. A Among their adversaries is the sharp-clawed yellow monitor lizard, an accomplished snake hunter. While the tree snake can miraculously scale even vertical tree trunks, it would be hard-pressed to compete with the monitor's climbing agility. What's more, the canopy isn't continuous. Wide gaps between the trees prevent an easy getaway. But paradise snakes have found a better way. When face to face at the moment of danger, tree snakes make use of a truly remarkable defensive weapon, worthy of James Bond's ejector seat. The moment of danger has turned into a moment of flight. To really understand this pilot's technique, it's best to start at the launch. Tree snakes will move down a branch end and beyond, falling into a J-shaped bend, leaning into the incline as if determining a destination. But once it's in the air, how does an animal with an inner tube for a body transform itself aerodynamically? After launching, it sucks in its guts and flares its ribs to make a U-shaped wing. Increasing its size adds to air resistance. But are these snakes doing anything more than falling with style? In super slow motion, their flight is even more spectacular than thought. The body flattens down to but a ribbon. And they appear to be assuming a degree of control, undulating as if swimming, holding the tail upwards and twisting from side to side for balance. Literally, snaking through the air may help it achieve some steering and sail distances of 300 feet.
I hope you found the movie about the snake. It's kind of creepy, but it's kind of cool. They do glide a long distance while they're moving and swerving. Okay, so next, let's talk how airplanes fly, right? So for these airplanes to fly, they need certain kind of forces to be acting upon them. So can you think of them? I'd like the class to come up with the forces that act on the aircraft.
Take a few seconds and look at your worksheet. See if you can fill in those boxes around the aircraft. What are some forces that an aircraft experiences?
So it turns out there are 4 types of forces acting on an aircraft. I hope you were able to discuss some of these, come up with some of the solutions, but let's take a look. So, as this aircraft is moving from the left, from the right to the left, there are 4 forces acting on it, one of which is the weight. This aircraft is heavy, as you can imagine. If there are no other forces acting, it will just fall. So that's the weight. As this aircraft is flying, it will experience what is called drag. So drag is something like if you're swimming inside a pool, and if you're trying to walk in the pool, you will feel the water hitting you. That is the same thing with air. The air is going to hit the aircraft and create some drag. That's called drag. Oops, sorry. Let me see. Now, to counteract these 2 forces, there are 2 other forces that you need to fly an aircraft. One is called thrust. In order for you to move forward, the aircraft needs to have some sort of forces that pushes the aircraft forward, and that's called thrust, which we'll talk about in more detail later. We also have another force that is absolutely needed so that you can stay flying, which is called lift. So these lift forces are being generated by the wing, as you can imagine. So let's talk about this in more detail. Okay, so first, let's talk about how you can create lift. Now, as you can imagine, these aircraft are critically dependent on the wing for generating lift. Now, if I were to take this aircraft and take the wing off, you'll see the shape of the wing, which is something like this right here that I'm showing in white. As the air flows over this wing from the right, left to the right, what happens to the air is very important here. So, we want to have the air being pushed downward. As you might have learned, if you push something downward, something has to act upon it to push it upward, right? So imagine you are pushing, for example, the skate link on one side, then the wall that you pushed on is going to push you the other side. The same thing happens with air. If you push down on the air pushes you right back up, and that creates a lift. You can also think about this from the point of view of the air traveling over the wing. If the air is being pushed down, what happens to the wing, the air around the wing is that the air goes around the top of the wing at a higher speed. So this creates what is called a low pressure region, which pulls the air upward, upward, which creates lift. So let's see if we can demonstrate that too by the use of a paper, right? So if I were to replace this aircraft wing with a piece of paper and have a high-speed air blowing over the surface, let's see if a lift force can be generated. So what we're going to do is we're going to imitate that by blowing over this piece of paper. So you can see that the piece of paper moved upward, and it's because we have a suction, low pressure region that pulls the surface of the wing upward. In this case, it's paper, but you can imagine that happens at a higher speed and a more massive amount of force being acting on the wing. So I'd like you to take a moment, see if you can find a piece of paper, try this experiment and see if you can indeed generate lift by blowing over the surface.
Use your worksheet paper and see if you can generate lift.
Okay, I hope you had fun generating lift with a piece of paper, demonstrating on your own. Okay, it turns out you can have different kind of wings, but these wings and size of the wings and shapes and all that are influenced by the speed of the aircraft and also the weight of the aircraft. So if the aircraft is heavier, you can imagine you would need a larger lift force, so you would need a larger wing to generate enough lift to sustain flight. But if you're flying at faster speed, it turns out you can have a smaller area. So if you can see this aircraft, this is called the F-104. It almost looks like a piece of pen, or like a pencil with a short and stubby wing, but it's enough to keep it afloat. And you can also have an aircraft now without any what's called a vertical stabilizer or a horizontal stabilizer. It looks just like a flying wing, and these things exist. Okay, so the other component we need to sustain flight is thrust. So the way we generate thrust is by using an aircraft engine. And if you were to take one of these engines and open it up, here's a photo of an engine with the cowling, or so the cover is opened up. This is what it would look like. It would have two sets of fans in the front and in the back. And what the front ones will do, it'll rotate at high speed, pull all the air into the engine, it'll mix it with the fuel, burn the fuel, and then expanded exhaust gas would exit from the back side. As it exits from the back side, there'll be the latter set of fans that will rotate, try to get some of the energy, and it is connected to the first half of the fans, and it keeps this motion going. So it'll suck the air, burn it, push it out, suck the air in, burn it, push it out. This continuous operation is going to pull the air in and create thrust, which would generate enough speed to generate lift. And that's why aircrafts fly.
That was a lot of information at once. Let's make sure you caught all of that. What are some forces that an aircraft experiences? An aircraft experiences 4 forces: weight, drag, thrust, and lift. There are 2 forces that act against the airplane as it's trying to take off and fly through the air. The weight of the aircraft and drag from the wind both act against the aircraft. These forces add to the complexity of flight and air travel. The airplane needs 2 forces to work with it to allow it to fly. These forces need to counteract the forces of the weight and drag that are trying to slow down the airplane and bring it down to the ground. The forces of thrust from the engines of the airplane and lift from the wind help the airplane climb and soar through the air.
Okay, next, let's see how a weather balloon can travel in the air. It's very similar to how an aircraft can travel. So I want you guys to discuss what are the forces that are acting on the weather balloon. It's similar to the aircraft, but it's for the weather balloon.
Think about how airplanes and weather balloons are similar and different. What are some of the forces that our weather balloons are experiencing?
Okay, so it turns out that the balloon experiences similar kind of forces. Okay, first, you'll have the weight of the balloon that's trying to pull it downward. And how to counteract it is by lift again. But you're not going to have these wings or engines on it that would generate the lift force. The way it's going to generate lift is by either having a light gas inside that is of a different gas, like helium, or you can actually heat the gas inside to make it lighter. So that creates lift. Now, instead of an engine, what will carry this balloon is actually the wind. So the wind will carry it, try to carry it to the left in this example, and also you would have to counteract the resistance of the air, which would be drag in this example.
Our weather balloons are experiencing the same 4 forces that the airplanes we talked about earlier experience. Weight and drag have the same effect against a weather balloon as they do against an airplane. However, thrust and lift are different. The thrust is created by the wind blowing through the air, which blows the balloon. Lift is created by a light gas inside of the balloon, such as helium or hydrogen, that allows the balloon to lift. In the case of a hot air balloon, that air itself is heated, which again allows the balloon to lift.
Okay, let me also talk about one of my favorite aircrafts. This is called a Boeing 747. This is something that I flew on when I was a kid, and it's kind of got me interested in aircraft. But it has been around. The first flight was back in 1969, and it's still flying. Perhaps not the same aircraft, but various versions of it is still flying, and you can find it in a lot of the airports still. It carries a lot of passengers. You can carry from 416 to somewhere close to 600 passengers. That's a lot of students, think about it. It can take off with a lot of weights. The empty weight of this aircraft is 400 pounds, or 400,000 pounds. So you can take additional 500,000 pounds, including fuel and passengers, and still fly, which would amount to roughly carrying about 50 elephants, which is kind of amazing. If you can imagine carrying one elephant, you can carry 50 of these in this aircraft. And to sustain this flight, you have 4 big engines. You can see right here, right? These 4 engines are the generators of these thrust, which translates to lift, and 63,000 pounds each are generated by these engines. And what's really cool is that the range of this aircraft is over 7,000 miles, which allows you to go over the ocean, the Pacific and the Atlantic Ocean, at a cruise speed of Mach 0.85 there. But as I said earlier, as you're generating lift over these wings, the local speed of the velocity here over the wing could be close to Mach 1, which means that you're approaching the speed of sound, which is very fast. Now, this aircraft is huge. If you have seen one of these aircraft, this is just really big. So if I were to give you the dimension, in length it's 232 feet long, height is 64 feet, and the width of this aircraft is 212 feet. Now, on your worksheet, I'd like you to see if you can draw a school bus. Just imagine what kind of size a school bus will be on this picture.
Take a look at your worksheet with an outline of a 747 airplane. How do you think a school bus compares to this airplane? See if you can draw it.
So, what did you guess? Let's see what the actual school bus or average size school bus would look like on this diagram. It would look like this, right? So this aircraft, school buses are big, but this aircraft is massive, right? In fact, if you have been to Washington, D.C., they have this airplane on display at the Smithsonian Museum, Air and Space Museum. It is so huge that it can actually fit only this part of it inside the building. It would just occupy the entire museum if you were to try to fit the entire thing. In fact, it won't even fit. Okay. Now, what's cool about this, us being in Florida, it's related to the space shuttle program. In fact, these aircraft, you can actually modify this aircraft to see if you can carry the space shuttle. So back then, if the space shuttle returned to Earth, and if it couldn't land in Florida, where we launched the space shuttle at Kennedy Space Center, sometimes it would land in California or in Texas, and to get back, what they used to do is they would get the land or the returned orbiter, and they would crane it up, they would piggyback it on one of these 747s, and then they will fly it and return it back to Kennedy Space Center. So there should be a video of this. I'd like to see if you can find it. It's pretty cool, it's pretty exciting. Well, let's see if you can find it. So let's see if we can relate the effect of winds and flying one of these aircraft. So if you were to fly one of these and try to go from Atlanta to Tokyo, it turns out you can get from Atlanta to Tokyo in 14 hours. It's a long flight, but you can do it. However, if you try to get back from Tokyo back to Atlanta, it's 12 and a half hours. Now, the flight distance is actually less than 7,000 miles. It's about 6,850 miles each way. So you can cover that with one of these aircraft. But why the difference? What do you think is causing the difference in this flight time? I'd like to see if we can figure that out.
Why do you think there's such a big difference in flight time depending on the direction you're flying? Jot something down.
So, did you get the answer? It turns out, just like the balloons, the aircraft can actually be influenced greatly by the winds. It turns out there's a strong jet stream that could go from 60 miles all the way up to 200 miles per hour that would travel from Asia towards the US. That's why if you're flying from Atlanta towards Japan, you would feel the effect of the jet stream working against you. But if you're flying from Asia to the US, you'll be riding that wave, which will make your flight time significantly shorter on the return trip.
Let's recap. The airplane is greatly influenced by the winds. Jet streams, or strong air currents, act against the aircraft when it's traveling from North America to Asia and cause a lot of drag. This jet stream has the opposite effect on the airplane when it's traveling from Asia to North America and helps push the plane along, making the trip a lot shorter.
Okay, now, in a few minutes, we're also going to try to have some fun using bottle rockets. We're going to be launching this bottle rockets outside, so you'll be able to see this live. And based on the concept that we just described here in these slides, I'd like to see if you can describe what will happen to the bottle rocket as it gets launched. So I'd like to see if you can take a look at your worksheets and fill in the gaps. Okay, so with a bottle rocket, what's going to happen is you guys are going to pump air into the bottle rocket. It's going to be pressurized. It's going to be held initially. And then there'll be some water at the bottom that will be released as this thing is going to fly. But what happens is, as this flies, there's going to be a tremendous amount of thrust forces that is going to be pointing downward, counteracting the weight. And because the force, the thrust, is much larger than the weight, it's going to start to accelerate really fast and try to go up pretty far off. As the bottle rocket empties out all the gas and also the water, it's going to lose all the thrust and experience only drag. And by the way, this bottle rocket at that point will be very light, and it'll basically slow down, and later the weight is going to basically win, and it's going to pull the bottle rocket all the way back down to Earth, and it'll fall back down. Okay? you had some fun learning about the flight, a lot about airplanes and balloons. So if you'd like to know more about it, you can come find us at FSU, the Florida State University. We have open house at the Aeropropulsion Mechatronics and Energy Building once a year. You can find more information on it online. I would highly recommend you guys to go to museums. We have the Challenger Learning Center in Tallahassee. If you're near Pensacola, there's a great Naval Air Museum. Of course, there's the Kennedy Space Center if you want to learn more about the space program. And if you're near Atlanta, there's a Delta Airlines Museum, which I hear is wonderful. And if you're in DC, there's the Smithsonian, which is magnificent. There are actually 2 museums there. I know some of the students here have gone to the local airport, but it's always a treat to go to the local airport and see the aircraft. And also, you can't beat flying with them. So with that, goodbye, and I hope you had some fun.